When chunk search keeps missing relationship-heavy answers, the fix is not always better embeddings. Sometimes you need retrieval over entities and edges. This is the pattern you'll be able to implement by the end, which builds an entity graph from documents and answers a hard question by tracing a two-step path. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Many question-answering pipelines rely on chunked text and vector search. That works for facts inside a single paragraph. It fails when the answer lives across linked entities. Multi-hop questions need traversal, not just local context. Neo4j GraphRAG in Python solves that gap by turning text into a tiny knowledge graph and using graph queries to find relation paths that connect the dots. At a high level, we build nodes for entities and edges for relationships. Then we ask a question. Pick the most relevant entities, walk a path of 1 or 2 hops, and assemble an answer from the connected facts. The strength is clear reasoning along edges. The trade-off is upfront graph modeling and a few extra queries, which usually pays off for relationship-heavy questions. We will build a compact example. It uses Neo4j as the graph engine, token-based matching for entity recall, a 2-hop Cypher traversal for the multi-hop, and a small template to format the result. The goal is to see how retrieval and traversal replace a failing chunk search, and to keep the code approachable before we dig into details. Now we will check the Neo4j connection readiness. This snippet checks a live Neo4j connection using the official Python driver. It imports GraphDatabase, creates a driver with a local both URI, and opens a session for a quick probe. The session executes a trivial Cypher query, returning one value, stored in the variable OK, a timestamp captured before the call, and another after, allow computing elapsed time in milliseconds. Using the variable driver keeps the handle reusable for later steps in the workflow. The call to s.run with a Cypher return of 1 as OK demonstrates a real query executed against Neo4j through the session. The printed result confirms the database is reachable and gives a quick latency feel. Next, we will seed a minimal knowledge graph, so multi-hop patterns have something to traverse. This example seeds a minimal knowledge graph in Neo4j to support GraphRAG. It builds one company that makes a product, another company that acquires the maker, and a founder linked to the maker, all in a single Cypher create statement. The variable Q holds the Cypher text, and s.run of that text executes it over an active session created earlier. The call to consume retrieves a summary with counters, which expose nodes created and relationships created, useful for quick validation. Keeping entities compact makes multi-hop patterns easy to reason about later. The printed counts confirm the base graph is in place and ready for retrieval. Now we will score candidate entities from a user question using simple token overlap. This code scores entities by matching query tokens to the name property in Neo4j. The variable QText holds a user question, and tokes stores normalized tokens using the regular expression to strip punctuation and case. The Cypher query collects hits per node with a list comprehension and returns a score based on how many tokens appear in the entity name. Results are ordered with order by, so the top match is stable. The session call to s.run pushes tokens as parameters, and rec receives the best row, increasing token strictness. For example, by filtering short common tokens, tends to reduce false positives. The print shows which entity best matches the query context. Next, we will traverse the graph for a 2-hop answer from product to acquirer. This example answers a multi-hop question by chaining relationships in Neo4j. It filters the product node with a token, then matches a company that builds that product, followed by a second company that acquired the builder. The variable q holds the cipher that traverses 2 hops, and s.run of q with a parameterized token list executes it with stability. The result uses aliases product, maker, and acquirer to make downstream use straightforward. If you broaden the token list, the traversal may return more candidates and increase ambiguity. Narrowing tokens focuses the path. The printed values reveal the acquirer and the maker discovered via the graph. Finally, we will format a small RAG-style answer that cites the discovered facts and a confidence score. This code assembles a concise RAG-style answer using facts pulled from Neo4j. The Cypher query fetches the product, its maker, and the acquirer, returning a small support score S for a lightweight confidence signal. A session executes the query and stores a single record in rec for templating. The variable ANS formats a human-friendly sentence that cites the discovered entities in context. The confidence metric scales with supports and is clipped with min to remain in a sane range. Increasing S raises the final confidence. The printed output provides both a readable answer and a numeric confidence that communicates strength. In a real project, this toy flow maps directly. The entity creation step becomes an extractor from your documents. Token match scales into a lightweight candidate recall stage. The Cypher 2 hop becomes the spine of multi-hop reasoning, and the answer template feeds your LLM or user interface. Recap. It is a pattern that builds an entity graph and uses 2-hop retrieval to answer relationship-heavy questions. Use it when single chunk retrieval misses linked facts or when provenance along edges matters. One caveat, it requires reliable entity extraction and graph modeling upfront. Next step, scale and evaluate this pipeline by adding a vector-based entity index for fast candidate recall, and then measuring timing and accuracy on a larger corpus. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.